Okay, now in trigonometric limits, there are some rules. As I told you, I'll be making a video where I will explain you the proof. But today we are just taking the formula the way it is. Limits x tends to 0, sin x upon x is 1. For the same reason, limit x tends to 0, tan x upon x is also 1. The third thing, which is a very obvious thing, x tends to 0, and this is cos of x will be 1 because cos 0 is 1. Now here, the important part is the angle should be repeated. So let me give you some examples and then we'll move to the exercise questions. So limit x tends to 0, you have sine 25x upon x. So you need to solve this. So what do we do in that case? You multiply 25 up and down. So you have sine of 25x upon 25x. So you get 25 into 1 and the answer is 25. So this is one way to understand that the whole angle needs to be repeated. And now another important thing. So if this is sine square x, then in the denominator also you need a x square. And generally we prefer writing it this way. This is sine x upon x the whole square. And then the answer is 1 square, which is 1. So if you have limit x tends to 0, sine square 3x, and down you have x square. So here, as the angle was repeated, so here also the angle needs to be repeated. And you can do that by multiplying 9 up and down. So what do you have now? Limit x tends to 0, 9 times sine square 3x. And here this is 3x squared, which can be written as sine 3x upon 3x the whole square. It's 9 into 1, which is 9. I'll just make a list of those formulas here. So one which is commonly used is cos 2 theta is 2 cos square theta minus 1. 1 minus 2 sine square theta. Okay. So this, according to me, is a formula that is used a lot everywhere. Okay. This particular exercise, we may also use sine 3 theta. That is 3 sine theta minus 4. Okay. And the same thing for cos 3 theta will be 4. So this is another one which will be used a lot. Okay, only thing is there is a negative here. So in place of C minus D, we do D minus C. So the formulas which are there in the compound and multiple angle chapter, they are important. So you use them multiple times, so you tend to remember them. We know the formula, limit x tends to 0, tan of an angle upon the same angle gives you 1. So here this is half x. So we need the same angle below. So limit x tends to 0. This is tan x upon 2. So this needs to be x upon 2, but there's a 3. So we need to multiply that with 6. So nothing changes. And now taking the limit, what we have, this is 1 into 1 over 6. The answer is 1 over 6. Let's go to the next question. Again, we go with the form. That is sin x over x is 1 when we have limit x tends to 0. So this is a formula that we have. Now, since this is sine square, we need a x square below. So I'm writing dividing numerator and denominator by x square. So this is limit x tends to 0. This is sine square ax upon x square. I can write it this way. Okay. Now we know that the angle needs to be repeated. So this is ax square. So the square of that, we need a square. And the square of this, we need a b square over here. So there is a b square down. So then that can be written as limit x tends to 0, sine of ax upon ax squared. And this is bx and here you have a square upon b square. So taking the limit, here we get 1 square, and this is a square over b square. That will be the answer. Okay, moving on to the next question. Limit x tends to 0, sine square 5x, and this is 15x. There is sine square, so we need a x square. So dividing numerator and denominator by x square. So this is sine square 5x over x square, and this is x square. This is sine 15x. Again, we repeat the angle. So this is a square, and this is 5x. So we need a 25 down. So I multiply by a 25 on top. This is just 15x. So I will write 15. And I have to get rid of this x, which I'll do in the next step. So I have limit x tends to 0, sine of 5x upon 5, the whole square. And this is 15x. This is 15x. This will reduce as 5 and 3, and the extra x, this comes over there. Taking the limit. So we have 1 square, 1, 5 by 3, and this is a 0. So the answer to the question is 0. Moving to the next one now. Okay, this is question number 12. You can see there is sine, just a single sign. So dividing numerator and denominator by x. So this is limit x tends to 0, 1 upon x. And here you have sine 2x, sine 6x. This x goes below each sign. So this is sine 2x upon x, sine 6x upon x. And then we have sine 5x upon x. Okay. The angle needs to be repeated. So 2, this is a 2, this is 6, this is 5, and this is 3. So now taking the limit. So this is 8 over 2. Answer is 4. So remember, you don't need to do anything more complicated. That's sine plus sine minus sine form, when you can do this easily. Okay, moving to the next one now. Now in this question, we have cos minus cos. So we know cos minus cos is negative of 2 sine. So we can apply that here. Limit x tends to 0. So there was a square in the denominator, and it's a product of sine into sine. So here we can take sine upon x and sine upon x form. Okay, so let's do that. This is limit x tends to 0, 2 times sine of m plus n upon 2x, and I get an x here. Sine of n minus m upon 2x, and I get an x. As we have done before, the angle needs to get repeated. So here this is m plus n upon 2, and this is m plus n upon 2. This is n minus m upon 2, and n minus m upon 2. So this 2 can get cancelled over here. So yes, now that's it. We can take the limit. So taking the limit, this thing is 1. Okay, and yes, you should know that as x tends to 0, this whole number into x also becomes 0, and the same goes with this as well. So what we have over here is 1 into 1 into n square minus m upon 2. So n square minus m upon 2 is the answer. There's one another way of doing that, doing this particular question, is I can add a plus 1 and a minus 1 here. So how does that change the question? Let me just delete this and show that to you. So here we have limit x tends to 0, and you have cos mx minus 1 minus cos nx plus 1. And here this is the x square. I can write this as negative of 1 minus cos mx. And here I can write this as 1 minus cos nx. Okay, now we know cos 2 theta is equal to 1 minus 2 sine square theta. On rearranging, we get 2 sine square theta as 1 minus cos 2 theta. So applying that here, we get negative of 2 sine square mx by 2. And here you get 2 sine square nx by 2, the whole upon x squared. What do we do now? We can write this as limit x tends to 2, x tends to 0. You can take the 2 out, and here you have sine square nx upon x square minus sine square mx upon 2 upon x square. The angle needs to get repeated. So therefore what we have is limit x tends to 0, this is 2, and this is sine square nx upon 2. So we need n square upon x square upon 4. So that means there is n square upon 4 over here. And the same thing, that is sine square mx upon 2. And here you need m square x square upon 4, which is m square upon 4. Taking the limit, you will have 2. This is 1 square n square by 4, 1 square m square by 4. Okay, so you get the same answer. So that's another way of looking at it. So 1 minus cos 2 theta is 2 sine square theta. In the same way, 1 plus cos 2 theta is equal to 2 cos square theta, half angle formula, quite useful.